Good morning, a very good morning to everyone. Today we are learning about the basics of dimensional formula. What we are going to learn? The basics of dimensional formula. What is this dimensional formula is? So a dimensional formula is simply what we know. Dimensional formula is the powers of your fundamental quantities. I think you might have learned what are fundamental quantities as I described, had taught you before in the video. So let me know. Let us take a formula of area. You know what's the formula of area? Area is equals to length into breadth. As we know, length into breadth. You might have learned in your lower classes, and the length is measured in terms of meters, and also your breadth is measured in terms of meters. Finally, we got meter square, and this is how we got is you might have learned in your lower classes about exponential formulas, that is a power m into a power n is equals to a power m plus n. Yes or no? You might have not known how it is used in physics, but now you come to know it is used in dimensional formula for every kind of your mathematics problems. It is involved in your physics. So don't neglect your mathematics problems or formulas. So let's go for the next. And your dimensional formula will be written for area is in this manner. If you know the units of area, this is called SI units. What we call SI units. And now the area will be written. We need to place in a square bracket. We should not forget. If we are not finding any of the mass in the above terms, we can place m power 0. And it is an L term, so L power 2. And also there is no t terms, so I am writing t power 0. Or else you can also define your dimensional formula in this manner. So your length into breadth. Directly if you can substitute, then also you are going to get the same thing. So this is how what we have. This is L and this is L. These are the two dimensional formulas for length and breadth. And now again we got this a power m into a power n is equals to a power m plus n. So this is how we got. This is L, and here we have, if there is no powers, then we need to consider it has 1. So it is also 1. So 1 plus 1, it is L power square. So simply we call it as L square, not L power square. It's L power 2 or else L square. Let's go for your volume. I think these all are basic formulas you have learned in your earlier classes. So this is, we have L m power 0, L cube and t power 0. You might have doubt how you got this. So let me go into your formula. A basic formula for volume. We will find this volume formula as length into breadth into height. Yes or no? For finding the volume of any cuboid, what we will do? We will take, what we will take? We will take length and it is height and it is breadth. Length into breadth into height. The same thing I took. And here I directly took about your L terms, your dimensional formulas. Dimensional formula. And this is how I got 3 L's. And now what I could write? I can observe 1, 1, 1 at the parts of L. So it is in the form of a power m into a power n into a power L. So I can write a power m plus n plus l. Yes, the same thing I had to produce. Same thing I had to do for these l's also. Then l power 1 plus 1 plus 1. Hey, it's 3 l cube. So finally, if you go through your units, again it is meter cube. This is your SI unit of volume. So I can write in a complete form like m power 0 l cube t power 0. So let's go for the next one. Your next one comes with your velocity. Which city? Velocity. It's not another city. It's simply a physics city we call as velocity. And this velocity, we have a formula, displacement by time. What we have? Displacement by time. And you might have known a little bit knowledge. If a person is moving in a forward direction, your displacement will be equals to what? The distance. Only if a body is moving in a forward direction is equals to distance. Otherwise, it is not possible. So now, if a distance is written in the form of your displacement, then it is always measured in meters. You know well. So length or a distance, whatever it may be, you are measured in meters, not it is measured in kgs, or else it is not measured in seconds. It is measured in meters. So I can write, if it is a forward movement, so I can write displacement is in terms of meters, and your time is always measured in seconds, not else it is measured in meters, or else it is not measured in kgs. So I am writing seconds. So finally I can write meter per second, or else I can write meter second inverse. Everything will be equal to 1. That is the unit of, this is the units for velocity. These are SI units. So now let's come to the turn of how we can write this dimensional formula for this. So dimensional formula I can write directly by using this. By using this units in the terms of m, I can write L, and in terms of second inverse, I can write t power minus 1. Finally, I got a dimensional formula. Or else, if you have any confusion, let us substitute from this formula. From this formula, what we come? Here, displacement is meter length and time is t. So, as we know in earlier exponential formulas, that is 1 by a power m is equals to a power minus m. So what is happening here? The a power m is sitting in the denominator. When it comes to the numerator, it has to wear a cap. See, this is a cap. So don't forget to place a cap onto the m or any power which is coming to the numerator. So this is how I can write L t power there. T is wearing a cap which is of minus 1. So if there is no parts we can observe, then we have to place 1. What we have to place? 1. So finally, it's a dimensional formula of velocity, m power 0 L t power minus 1. If we learn this velocity, we had to call a friend of velocity as acceleration. No, it's a speed. Speed is a friend of velocity. So this is a formula of speed is distance by time. Distance by time. So how much the distance can be traveled in what duration of time? In 1 second, we call it as a speed. So now the speed, again, it is meters and time is measured in terms of seconds. And this is again meter per second. You need to remember this divide will be written as per second. If it is square, then you will read per second square, or else per second. So we need to remember this. A slash or a divide is simply learned as per or read as per, and it is written as meter second inverse. Yes, you're right. Then, and now it's the turn of dimensional formula. So how we can write the dimensional formula? The same manner what we have written in the above one. So this is the dimensional formula for speed. So let's enjoy this. Your meter, it is in length, and t, it is in denominator, And then again it can be written as T, L, and T is wearing a cap and coming to the numerator, that is -1. Finally, we have m power 0, L, T power -1. These are the basic knowledge we have to go for learning your dimensional formula before you jump into your formulas, before you jump in your terms, you have your fundamental terms has been converted into taking some other. So let us take your acceleration. Acceleration. We have a formula for acceleration is velocity by time. Which city? Velocity by time. Yes, now it's velocity by time. You know, earlier from the above we have learned velocity is meter per second, and again we have second. Yes, now what is happening here? And second is going to adjust with the second in the denominator. Yes, both are both are joining with them. And again we have second square. How we got this again? Again it is in the form of a power m into a power n. It is equals to a power m plus n. Then it is m power second square. Why? Because it is actually 1 plus 1 in the denominator, m by a second square. And how? Meter per second square we have to call. It is for reading purpose. And coming to this, I can also write meter second per -2. Yes, then. As it wearing a cap, when it comes to the denominator to numerator, it has to wear a cap called minus. Don't forget that. And now, what we have? A dimensional formula we need to find. Your dimensional formula for acceleration. Hey, it's not difficult. You should not feel a difficulty for finding out how we have to do this dimensional formula. Always we are writing MLT, MLT. What is this MLT? MLT is a fundamental units. So what is this M? M stands for mass and L stands for length. And finally your T stands for time, not your temperature. Remember this. So every time we need to measure, we need to express this dimensional formula in terms of parts of fundamental units. So fundamental quantities you have to learn. Don't forget to learn that. And dimensional formula of acceleration. And this is how directly we can use this for your units. If you have learned your units, you can directly get this dimensional formula without any confusion. Here no m terms, we can't find any cases here. So I'm writing m power 0 and we can find only m. So in terms of m, I'm writing L. And in the case of your second power -2, I'm writing t power -2. That's it. This is how we can find a dimensional formula. Again, if you go through your formula again, here we have meter and we have second square. And for this, I can write L and t power -2, t power 2. And again, when it comes to the numerator, it is wearing a cap called t power -2. This is also one of the way to find your dimensional formula. So you should not worry about this. Let's go for the next formula. That is your force. Force, you know, every time it is forced to you to learn. So let us go for your force. Force is equals to mass into acceleration. So see how it is related. In terms of your acceleration, acceleration is related with your velocity. And now your force is related with acceleration. Nothing has to believe. Everything we have to learn. So here we have kgs. And just before we have learned it is meter per second square. So how we have to read this slash? It is in the form of power. Okay. And again it is m power 0. L, and it is in denominator, we can write kg meter per second, so else second power -2. So now L t power -2 Hey, we got this. So again, don't forget, when it is in denominator, it has to wear a cap of minus. What it has to wear? It has to wear a cap of minus.